Hey, come on in. Welcome to the chemistry lab that we converted into artist studio. Our essential question in this unit is how can we use reactions to make a piece of art? And also, what's the connection between art and chemistry? What I'm going to do in this video is I'm actually going to take you through the stations and make sure that you understand the chemistry behind each art technique. So first off, come on over here. We have our paint station. Alright, so with the paint, you're dealing with the type of reaction we studied called precipitation. And that's when you take two ionic aqueous solutions and mix them together, and they form a solid compound. And if that solid compound is colored, it can make a paint. So, for example, if we took cobalt chloride and sodium phosphate, put them in some water and mix them together, we would get a paint color called cobalt purple. And when you do your model, if you're painting, it would look something like this. You'd have your cobalt chloride chemical, which is aqueous, your sodium phosphate, which is also going to be an aqueous solution. Find the ions. Swap the pairs. Do the crisscross method. There's a whole video on this that walks you through its flow. Use your solubility table. You'll find that this is aqueous and this is solid. So this compound is going to be solid purple, and if you dissolve it in something like linseed oil, something like that, or even if you just keep it in water, you have something suddenly that you can paint with. You got to make one precipitate using these chemicals, and then we have a bunch of other just regular paints that you can supplement with. Paintbrushes, filters if you want to get the water out of your paint. Come on over to our clay station. Over here with clay, with clay, what's going to happen is you leave it overnight and it does a dehydration reaction and dries out. In class, we said that what can happen is that ionic compounds can form these crystal structures. We looked at an ionic compound that was made of, for example, the crystal was, this is just representing the crystal, was made of copper sulfate. And what water can get trapped inside of the crystal structure. And when you heat it up or let something sit out for a long time, the water leaves the crystal and it becomes dry. So when you're dealing with clay, you want to look back at your notes on dehydration reaction and understand that there are crystals inside the clay that are holding water inside, and the water is leaving as it sits overnight. And the reading that I posted on the document that you all shared with me goes into more detail about what those chemicals actually are. Because in clay, it's not copper sulfate anymore. It's different ionic compounds. So that's our clay. Come on over to the electroplate area. With electroplating, you're doing a redox process that involves oxidization, which means losing electrons, and a reduction, which means gaining electrons. You take a metal that you would like to electroplate. Remember, electroplate just means coat one metal with another metal. So you take the metal you want to electroplate, and what you do is you use this battery, which we said acts like an electron pump, and the negative terminal of the battery actually kind of pumps electrons out. So we're going to hook that up. It'll give the surface a negative charge. Alright? And then the battery on the other end can suck up electrons away from something. So we'll stick our metal that we want to coat with on the positive terminal of the battery. And then we go ahead and we're going to put those in an aqueous solution that already has some copper ions inside. And what that's going to do is it's going to allow the ions, the copper ions, to flow from the copper metal over to the metal that you want to electroplate. The electrons are pulling, the battery's pulling electrons away from the copper, causing copper 2 plus ions to form in the liquid. And then those copper 2 plus ions, because we said this was negative charge, the copper 2 plus ions get reduced and deposit onto the surface. And if I were to let this sit in here, it would have a copper coating to it. So that's your redox reaction, losing electrons and gaining electrons. I hope this video was helpful to you. Good luck on your art project.